Today, we're going to be presenting the effects of global warming on coral reefs. I am Samin Abdallahi.
I am Royce Nguyen.
I am Julene Ross, and we will be presenting about causes of reduction of coral reef populations with a focus on global warming. To begin, I would like to say that the coral reef is a home and nursery to millions of species, such as seahorses, sea turtles, lobsters, and more. It is known to provide support for about 25% of marine life. The coral reef ecosystem benefits almost everything it comes into contact with. It protects the coastlines from storms and erosion. It creates job opportunities for those that live along the coast and gives local communities extra income due to tourists. The coral reefs provide food to those that inhabit it and billions of people. Although coral reefs cover only 1% of the ocean, ecological imbalance would occur. Removing coral reefs would result in millions of sea life species suffering, which means humans would lose most of their marine food sources and the economy would take a hit. Humans would have to start fishing down the food chain in order to find marine food sources. From what I stated, we can infer that the coral reef ecosystem is very important for the environment, the economy, and people all over the world. The purpose of our presentation is to bring awareness to the reduction of the coral reefs and what is causing it.
A scholarly journal from 2011 provided a prediction of future coral reef population based on historical coral reef responses to rapid climate changes. This figure shows the sea surface temperature and CO2 content of the Earth and extinction rates of coral reefs from the Proterozoic period to the Cenozoic period. You can see that wherever there are drastic changes in temperature or CO2 content is where there are spikes in the total extinction rate following the drastic climate changes. Notice that the temperature does not have to always increase in order to affect coral reefs. For example, the extreme temperature drop during 250 to 400 million years ago is the Ice Age, and it is followed by a large spike of coral reef extinction. We are currently living in the Cenozoic period, and you can see that we are currently experiencing a very steep spike, which means that coral reef populations are quickly going extinct due to climate change and human activity. Another scholarly article from 2011 provided statistics of coral reef bleaching throughout the Earth. Coral bleaching occurs when stressful environments, such as sudden extreme temperatures, trigger coral reefs to expel the zooxanthellae that were inhabiting the coral's tissues. As the algae leave, the corals lose color until they turn white. In 2011, the highest reports of coral reef bleaching were along the Arabian Gulf and the Red Sea. But in 2019, the Great Barrier Reef, which is along this tip of northern Australia, experienced one of the worst mass bleaching episodes, and it was not due to El Nino, which elevates ocean temperatures by bringing warm water to the surface. This is a clear sign that human activity is responsible for the coral reef bleaching.
Some possible solutions for the coral bleaching problem include proactive methods such as climate change mitigation by using new technology and new renewable energy, making old equipment more energy efficient, and changing management practices or consumer behavior in order to reduce or prevent emissions of greenhouse gases. Marine protected areas, which aim to conserve biodiversity, improve resilience, and enhance fisheries, protect and restore endangered species and ecosystems, and improve water quality by including adjacent watersheds as a means to control the impacts of sediments and pollution. Shading and cooling, which involves reducing solar radiation during high-risk periods for coral bleaching by creating shade through clouds, mist, fog, or surface films. Reducing overfishing, specifically herbivores such as parrotfish that graze coral damaging algae. Some restorative methods include direct transplantation, which is the most common method used to restore coral reefs. This is done by using fragments from fast-growing donor reefs and directly transplanting into recipient reefs. However, continuous harvest of coral fragments can have a baneful effect on the donor reef. Corals restored using this method reported to have an average survival rate of 64%. Coral gardening. This method is a more sustainable version of direct transplanting by using small fragments that are raised in intermediate nurseries. Once these fragments have reached a suitable size in the nurseries, they can be replanted and can be used to make more fragments. Corals restored using this method reported to have an average survival rate of 66% in outplanting phase. Microfragmentation. This method involves cutting small fragments using a diamond blade and mounting the fragments on tiles for about 12 months. After 12 months, the fragments are ready for replantation or to generate new microfragments. The replanted microfragments are secured to reef substrates and dead coral skeletons, which will fuse to form a larger colony. This method can be used to restore massive corals with low growth and thick skeletons. Corals restored using this method reported to have high survival rates and rapid growth. Genetic diversity and asexual propagation. Using assisted fertilization or creating nursery stocks from the larva or brooding corals can be used for maintaining genetic diversity in coral gardens. It can also promote the growth of more resilient coral species. Larval enhancement. Although corals produce millions of young, the survival rate for the young corals is very low. This method of restoration uses two different ways to enhance the survival rate of the larvae. The first method is larvae settled on artificial structures, which only has a 10% settlement rate. The larvae have 10% survival rate, but it has the highest speed of outplanting. And the second method is larvae settled directly onto the reef, which, according to long-term studies, has shown to have significantly enhanced the recruitment and reestablishment of a breeding population of tenuous colonies after 3 years. Artificial reefs involves the placement of substrum on the seabed to mimic the characteristics of natural reefs in order to increase potential habitat for reef fauna, fisheries production, recreational diving, or to prevent trawling. This method is developed in conjunction with coral transplantation, and corals restored using this method reported to have an average survival rate of 66%. Substrum stabilization. This method involves the use of stabilizing rubber for direct physical restoration of damaged substrum or install mesh or net over rubble to prevent further movement. Corals restored using this method reported to have an average survival rate of 80%. Substrum enhancement with electricity. This method aims to encourage the precipitation of calcium and magnesium on artificial substrata to mimic the chemical and physical properties of reef limestone. This method is considered controversial because experiments attempting to verify its effectiveness have had varied outcomes. We hope this presentation will give the general public more insight about how humanity is affecting coral reefs. Here are our works cited.